Hello everybody, welcome to day 2 of factoring. Today we're going to continue on our discussion of factoring. Last time we were looking at common factoring. Today it's going to get a little bit more complicated and it kind of carries into the next few days. So feel free through these next couple of days to review as many examples in the video as you want to, or if you feel comfortable doing the material after 1 or 2 examples, go ahead and do that too. Just note that at the end of the next couple of days there will be a bit of a summary highlighting some of the trends and patterns that we see amongst factoring in these problems, so it'd be important to kind of copy that information down. So today what we're looking at is factoring algebraic expressions with an a value of 1. So you've already looked at a standard form and a factored form quadratic, and you can see that right here is a standard form. So what's really of keen interest to us today is that leading a value. And all of the problems we look at today are going to have an a value of 1. So our concern is only really quadratic expressions with an a value of 1 for now. The whole point of us factoring is so that we can go from standard form to factored form, and will help us then graph parabolas. We can determine our zeros, we can determine our vertex and the vertex components of axis of symmetry and optimal value a lot easier from factored form, because each quadratic form will give us something unique. So in order to factor our standard form, we have to examine our a, our b, and our c values. So our a value is going to tell you kind of the process that you undergo for this. Our b and c values are going to be very important to us today, and you'll see that as we get through some examples. So we're calling again the standard form of a quadratic is ax squared plus bx plus c. Note when you see it laid out in a general form like this that you have the highest degree exponent first. So you have your x squared term first, you have your x term second, and then your constant is third. I would recommend that if you see an equation that is not in that order, that you actually do, especially when factoring. It will make things more consistent and easy as you move forward. So in order to factor quadratic in standard form, you need to find what we call our 2 magic numbers. We're looking at factors when we call these magic numbers. So they're very important to us. We use that term because it helps us remember a little bit. These 2 numbers need to be 2 factors of c that can add together to get your b value. So you're looking for 2 numbers that will multiply to get c. You multiply together, and when you add them together, you're going to get your b value. Okay, and that's their magic numbers. And I've already noted this. Be aware that the b value is always associated with your x term. In other words, the coefficient associated with the variable of a singular degree, and that your c value is always your constant not associated with any variable. Okay, so I would rearrange those things if they're not in the right order, or just be aware of that. Okay, you're going to see quadratics like so for the next few days that will have each of these terms. We may use x, we may use y, we may use a, b, other variables. You can see here that this example uses t as our unknown variable. The process is still the same regardless of the variables involved in your problem. Okay, so I'm going to go through a number of examples. The first one we're going to do in detail, and each one after that we'll do a little bit less, but we're going to follow the same pattern, and that's the same thing you have to do for every problem. So factor the following expressions. You can notice that these are in standard form. What I would do first when factoring is draw yourself a little t-chart off to the side of your problem, like so. Okay, remember we're looking for our 2 magic numbers. Okay, well, our magic numbers need to multiply to our c value and add to our b value. Well, our quadratic is in this form. Our c value is negative 72. Our b value is negative 1. So on the right side of these t-charts, I would put that multiplication symbol and whatever your c value is, negative 72. On the left side, you're going to put your b value and an addition sign. This highlights that we're trying to look for two numbers that multiply to 72 but add to negative 1. If you know these factors right away, you can go ahead and write them down. If you do not and you want to come up with a list so you can look at all of the factors, it might be easier to start that way. Well, what multiplies to be 72? You have 1 and 72. No way can you make these negative or positive and add to negative 1, so you keep going. 2 times 36. Again, they may multiply to negative 72 if you make one of them negative, but there's no way you can add to negative 1. Keep going. 3 times 24 is also equal to 72. 4 times 18 is equal to 72. 6 times 12 is equal to 72, and 8 times 9 is equal to 72. This one, or these two magic numbers, 8 and 9, are of particular interest. Well, if I have negative 9 and positive 8, that will equal negative 72. If I have negative 9 plus 8, that also equals negative 1. So these are the two magic numbers that I'm looking for. They multiply to negative 72 and they add to negative 1. What you want to do is, and I'm just going to rewrite the equation here first, is you're going to take those two numbers and you're going to split your middle term of negative 1x into those two magic numbers. So this is now negative 9x positive 8x minus 72. This has now just become these two terms here. This whole process of what's going on right now is what we call factoring by decomposition. What you're essentially doing, and that's what decomposition means, is breaking apart that middle term to become our two magic numbers. That is the first step. So 1, find your magic numbers. 2, factor by decomposition, meaning break apart that middle term. Next, you're going to want to group your terms into pairs. So your first two terms, are going to be paired together, and your second two. Okay? And like the other day we were common factoring, that's what you're going to do now. You're going to common factor these pairs. Well, you're asking yourself, what is common amongst x squared and 9x? What's common? Well, there's no value. It's just x is common to both. If you factor x out of both of these, you're left with x minus 9. Because you factor x out of x squared, you're left with x. You factor x out of negative 9x, you're left with negative 9. Same thing here. What's common to 8x and 72? Well, they don't have a variable common to one another, but they both can be, you can both factor 8 out of both those terms. Well, if you factor 8 out of 8x, you're just left with x. If you divide that out, and negative 72 divided by 8, well, that's negative 9. At this point, you notice something. You notice that you have the exact same thing left in your brackets. If you have the same thing in brackets at this step, then you're right. You're almost done. But this means you're on the right track. You haven't made a mistake. This is what it should look like. And we're going to go back to what we did at the end of our note last time. Well, what do you see that's common amongst this term here and this term? X minus 9. So rewrite x minus 9. if you have that, what else is left over? If you were to factor those both out, well, you have x and you have 8. Therefore, what's left over is x plus 8, and you factored your first problem. This process can be tricky, but go through a number of examples. If you think you have the hang of it already, feel free to keep working on your own pace, but we're going to do a number of examples. Okay, again, next problem, x squared minus 13x plus 36. Draw that t-chart off to the side. Okay, what we're looking for is two numbers that multiply to our c value and add to our b value. In this case, our c value is 36. Okay, our b value is negative 13. Okay, well, whatever our factors are 36. 1 times 36. 2 times 18. 3 times 12. 4 times 9. Okay, those are our factors. You can keep going, 6 times 6. However, what's important to us here is this set of factors right here, 4 and 9. Well, 4 times 9 equals positive 36, but 4 plus 9 does not equal negative 13. However, if I change both these values to negative, so negative 4 and negative 9, so you have negative 4 and negative 9. Negative 4 times negative 9 does equal positive 36, and negative 4 plus negative 9 does equal negative 13. So those are your two magic numbers. Again, the next step here is to split that b value into your two magic numbers. And that's what we just did here. That negative 13x has become those two magic numbers. What we want to do is pair our terms together and then common factor. Well, what's common amongst x squared minus 4x? Just x, leaving us with x minus 4. What's common amongst negative 9x and 36? Well, 9. If you factor that out, you're left with x minus 4, because 36 divided by negative 9 is negative 4. Again, you notice that we have the same thing left in our brackets here, x minus 4. That means we're correct. We're going to rewrite that. And if we were to eliminate that, what would we be left with? We have x here, and we have negative 9, and therefore we have factored our next problem. First of all, we need to change this first problem because there's a mistake. For this to work and to be factorable, we need to change this problem to x squared plus x minus 6, not plus 6, and that's what you see there in the t-chart to the right. So we're looking at two values that will multiply to negative 6 but add to positive 1. Well, the only factors of 6 are 1 and 6 and 2 and 3. Now, if the c value is negative, well, we need to obtain a negative. 2 times 3 is not going to get us there, but negative 2 times 3 will. And negative 2 plus 3 is also going to add to 1. So once you've identified that, we're going to split that middle term into our two pairs. Next, we're going to pair those together, and we're going to common factor. Well, what's common amongst x squared and negative 2x? X, leaving us with x minus 2. Because if you divide x out of x squared, you're left with x. If you divide x out of negative 2x, it's just negative 2. And here, what's common amongst 3x minus 6? Well, that's 3. That leaves us with x minus 2, because if you divide 3 out of 3x, you're left with x. If you divide 3 from negative 6, you are left with negative 2. We have the same thing in brackets, which means we are just going to write that down. If we eliminate that, we're left with x plus 3, and then we factored that problem. Okay, try this one here on your own, because it's similar to the first three, and see if you can get the answer that I will appear here in just a second. Okay, so we're looking, again, I'll review what we did here just so you're checking your answer. Negative 8 is our c value, negative 2 is our b value. Okay, we needed our factors of -8, 1 and 8, and 2 and 4. In order to obtain a negative number of -8, one of our factors, or our magic numbers, had to be negative. Well, for this to work, it needed to be -4 times 2, which is -8, and -4 plus 2. Therefore, I split my middle term into those two magic numbers, and then I paired my first two terms and my second two terms. Here, what I did was common factor. Okay, and I noticed I got the same thing in the brackets, so I rewrote that here, and whatever was left over, which was x minus 4, was rewritten in my second bracket. Okay. Hopefully we're starting to get the hang of this a little bit. Practice makes perfect, so keep trying even if you're not understanding just yet, and ask some questions if you have to. What you notice about the last two problems here, and this is what I was making note to originally, is the fact that our equations are not arranged from highest degree to least degree. So first thing I would do is do so. Well, our x squared term should be first, our x term should be second, and our constant c value should be last. This way, when I'm making my chart, I actually have the right values. I'm not making a mistake there. My c value is 35. My b value is 12. So what multiplies to 35 and adds to 12? Well, the only factors of 35 are 1 and 35, and you can't add those to get 12, but 5 and 7. You can add 5 and 7 together to get 12. Now again, split that middle term, x squared plus 5x plus 7x plus 35. Okay. Pair these together. What's common amongst your first two terms? X. What's common? What does that leave you with? Well, x squared, if you factor out x, you're left with x. 5x, if you factor out x, you're left with 5. What's common amongst 7x and 35? 7 is. So if you factor that out, you're left with x plus 5. What's in the brackets? X plus 5. What would be left over is x plus 7. In our last example here, same thing, we have to rearrange first. Okay, so rewrite your equation from highest degree to least, which means it's x squared plus 9x plus 14. Okay, now we're looking at values that multiply to 14 but add to 9. Our only factors of 14 are 1 and 14, that doesn't add to 9, and 2 times 7. So we're going to, again, split that. Okay, we're going to pair our first two and our second two terms and factor out what's common. X is common to both our first terms, leaving us with x plus 2. 7 is common to both our second terms, leaving us with x plus 2 if you factor it out. Okay, what's in your brackets? X plus 2. What is left over? X plus 7. And therefore that would be our last example of today. Now I understand factoring can be tricky and you might have a lot of questions, so please shoot us an email if you have any of that, or post it to discussion boards. But at first I want to highlight some summary and some trends that might make your life a little bit easier. Remember, these things are only in reference to those factoring problems with an a value of 1. So at the bottom of your note I would highlight some sort of summary. Okay. Well, the first thing I want to point out is a few trends. So what do you notice about your magic numbers that you've chosen when C is positive and when C is negative? So let's just scroll up here. So here's a great comparison. So these two examples here and here have a negative C value. So you have -6 in this example and you have -8. Whereas the second two examples here and here have a positive C value. Positive 35, positive 14. Okay, what do you notice about your magic numbers? Well, when it's negative, here, you needed to have -2 and positive 3. Here, you had to have 2 and -4. you notice that one of your values is positive and one of them is negative. That has to be true every time. When you're trying to multiply to obtain a negative number, one of your factors, your magic numbers, must be negative, one must be positive. That's the only way you're going to obtain a negative value. So let's make that note. When C is negative, you must have one negative and one positive number. So when you're choosing those, one has to be positive, one has to be negative. Now, when it's positive, so you have here positive 35 and here positive 14, you notice that both the values you chose were positive. So they're both the same sign. But what about our second example here? Okay, looking at 36 and negative 13. Well, our C value is positive, but the two factors we chose were negative 4 and negative 9. So whenever your C value is positive, you just have to make sure, I'm going back down here, that you have either two negative or two positive numbers chosen. Well, how do you know? If B is negative, then you're going to have two negative values. If B is positive, you're going to have two positive numbers. Okay, there's one more trend I want to highlight. And that trend is, what connection can you make between your answer and the two magic numbers you have chosen? Well, again, let's go up to just two examples is all we really need to look at. In this example here, the magic numbers you chose were 5 and 7. Look at your answer. X plus 5, X plus 7. Okay, what about the second one? The two magic numbers you chose were 2 and 7. Look at your answer. X plus 2, X plus 7. Keep going through other examples. The two magic numbers you chose here were negative 2 and positive 3. What do you notice about your answer? X minus 2, X plus 3. So if you want to summarize this, the magic numbers are the factors in your answer. i.e. X plus 4, X plus 3. What's in the brackets here is known as your factors, and the magic numbers you would have chose were 3 and 4. Okay. However, note and make sure you have this. This only happens when your A value is 1. So all the problems we looked at today were in the form y equals x squared plus, let's say, 12x plus 35. You notice that the A value is 1. So this trend that we just talked about here only applies to quadratics that have an A value of 1. Go through those examples, make sure you get the summary and the trends down, and do your best to get through those suggested exercises.